Okay guys, this is the second video for your review. We're gonna continue talking about slopes. Slopes as a rate of change. So in physics, maybe, like at your level, half of physics is going to be about slopes. So again, if I have a graph of position x in meter versus time in seconds, the slope is just going to represent the velocity, okay? So if I consider this graph here, so this slope here is going to be positive, meaning that the object or you are moving in the positive direction. This is, as you remember, a horizontal line, so the slope is 0. So what does that mean for the object? You tell me, the object, is it moving or is it not moving? It's not moving. It's at this position here. So at the beginning, the object is going up, moving on this axis. And then for, let's say it did this for 3 seconds, and here I had 6, and then here I have maybe 9. So my object started to move up until, let's say, 9 meters, okay, 9 meters. So it started moving from 0 to 9 in this direction. So this part here, the slope, is just going to be what? Rise, and then this is the run. So the slope here, or the velocity, is going to be rise over run, and it's just going to be the rise, which is 9 meters, over the run, which is 3 seconds, and then you've got 3 meters per second, and it's positive. Here, from 3 to 6 seconds, the object is not moving. The object is not moving, or what is another word, is resting, just at rest. So the object is not moving, is at rest. Or the velocity v is going to be 0. Now, for this part here, what is the object doing? So the object went, okay, up until 9 meters, and then it decided to take a break from 3 to 6 seconds. I usually joke with my students and say, if it's a bug or if it's an object, it's just, sunbathing, بيتشمس, okay? Then, after 3 seconds, from 3 to 6, so that's 3 seconds, it decided, okay, I want to go back home. So it went back like that, okay? So here, this rise here is not going to be positive. It's going to be the object, or the bug, is going down. So it's going to be negative. So -9. So if we ask you to calculate the velocity here, is going to be rise over run. So the rise here is not really a rise because this is going down. So it's going to be -9 meters over, from 6 to 9 seconds, the run here is just going to be 3 seconds. So -3 meters per second. Okay, for a bug, this is quite fast. And if they want you to describe the motion of the object, so the object went in the positive direction in the first 3 seconds, and then it decided to sunbathe for 3 seconds, and then after the 3 seconds, it decided to go back home, okay? So if we want to calculate the total distance, it went from here to here, 9 meters, and then 9 meters. So if we want to talk about distance here, let me erase this. You could always go back to it. So if we want to calculate the distance here, and we talked about this in our class, so distance is just going to be 9 meters and then 9 meters. So the distance is 18 meters, 9 plus 9. But the displacement since it went back to its original position, the displacement is just 0. Okay, so it's the final position minus the initial, the final position minus the initial position, which are the same here. So the displacement is 0. Okay, so again, for this part, the velocity was what? The velocity was 3 meters per second. For this part here, 0 meters per second, and we use rest. And then for this part is just negative 3 meters per second. Again, I hope that you completely understand this. If you don't, just shoot me an email. Okay, now let's move to acceleration. What's acceleration? Let's say one of you got his or her driver's license, which is going to be in a couple of years from now, and then you are on the highway moving at, let's say, 80 kilometers per hour. 80 kilometers per hour, that you're not changing. So you are not changing your speed here. It's 80 kilometers per hour. You decided to stay at the same speed. So that means you're not speeding up. You're not speeding up or slowing down. You are moving at a constant speed. You're not speeding up or slowing down because there is no change. You are moving at just 80 kilometers per hour. The quantity that we discussed and that talks about the change in speed or the change in velocity is going to be the acceleration. So the acceleration. The acceleration just measures the change in velocity, and I hope that you understand very well that velocity and speed, the difference between them is one is a scalar and the other one is a vector. So the acceleration is the change in v over the time taken, or the change in time taken. So again, physics is all about change, and you see here a ratio. So A is also, if I give you a graph of V versus T, A is also going to be a slope. So we better master our slopes. So A is also the slope. Is it the slope of a graph X versus T? No. A is the slope of a graph here of a V in meters per second versus time in seconds. So meters per second. If I have this, so I have a slope that is what? That is positive. It means that the acceleration is going to be positive. If I have this horizontal line, okay, you get it. I don't know if in the video it's going to show that it's perfectly horizontal, but you get the idea. So here, in this phase here, there is no acceleration because the velocity is constant. No change, no change in V, no acceleration. Change in V, there will be acceleration. Okay, so physics is all about change, and the change, the rate of change is just when you are given a graph, it's going to be a slope, so a rise over a run. So let's take this graph here. I'm gonna make it as short as possible. I know that you have some Fortnite games to play. Yeah, so, okay, V, this is a graph like this. Let's, okay, I'm just gonna put some numbers here. Okay, you could be asked to put some numbers, so just put some numbers. Okay, so I'm just gonna put 10. I love 10 meters per second. I wish I could reach that speed and be called Usain Bolt, I don't know. Okay, here it's going to be 1, and then here it's going to be 2, 3, 4, 5, and 6. So you've got this graph. What is this graph telling you? You've got to spend some time thinking about it before going on your computer and playing some games. Okay, so, but this is really interesting. You see, do we have like, so let's divide this as zones, and I'm gonna call this zone 1, this is zone 2, this is zone 3 from here to here, this is zone 4, like Romans, zone 5, and then zone 6. Okay, so in zone 1 here, is the velocity changing? Yes or no? Yes. You know, the values are different. It's starting from 0, which is rest, and it is increasing. So there will be an acceleration. And actually, what is this acceleration here? It's going to be this rise, which is 10, over this run, which is 1. So the acceleration here is going to be the rise over the run, and it's going to be 10 meters per second over second. So it's going to be, okay, this is 1 second here, the run is 1. You know, sometimes when things are so obvious, it's not easy to explain them because they're so easy. So it's going to be 10. What's the unit? Guys, boys and girls, please don't write meters per second. That's not velocity. This is an acceleration. Meters per second divided by second. So this is meter per second square. This is a very big acceleration. This is actually like the acceleration of a free fall. Okay? How about zone 2? No change in V. No change in V. So what does that mean? For the second phase here, the acceleration is just 0. This is a flat line, a horizontal line, no steepness, ما في أي ميل, you know, خط أفقي, ما في أي ميل. So the acceleration is 0, and the car or the object or whatever moving, imaginary or non-imaginary, is moving at a constant velocity, which is 10 meters per second. So in phase 1, the acceleration is 10 meters per second squared. That's huge. For phase 2, the acceleration is 0. And how about phase 3? If you want to think about it, you could pause the video, okay, for a while, and let's try to calculate it. So is this rise going to be positive or going to be negative? See, the line is going down. So for this part here, the acceleration is going to be, again, rise over run, and it is going to be what? This is not going to be counted as positive, right, guys? Because the line is going like so. So this is 10, but I'm going to put it as negative 10 because this line is going down. So it's the slope is negative, okay? And then the run here is from 2 to 3, that's again 1. So the acceleration is minus 10 meters per second squared, and it is negative, although the velocity here is positive. Okay, I wanna calculate. So let's say this is negative 10, okay? And I wanna calculate here the acceleration for this part. Go ahead and calculate it. Pause the video if you want to. For this part here, it's the same line, right? It's the same line. It's just that this part is positive and this part is negative. So of course, the slope of one line is always the same. So you should be finding for this part here also minus 10 meters per second squared. But we could show it. This is not a rise again, this is going down, so it's going to be negative 10, and this is 1, so negative 10 over 1 is going to be minus 10 meters per second squared. Phase 4, the acceleration is 0, and I hope you know why. The velocity is not changing. It's a horizontal line, a flat line, no steeping whatsoever. And then here, it's going from negative 10 to a 0, and you see that this is going up, okay? So this rise is going to be rather positive because this line is going up, so the slope is positive here. And so the acceleration here is going to be what? Is going to be 10 because it's going to go up over the run, which is 1. So the acceleration is 10 meters per second squared. And again, this is not a really realistic acceleration for an object. This is the acceleration of gravity, actually. But I just wanted to show you a graph of v versus t and how you can calculate the acceleration. Now, can you please pause the video and think about where the object is speeding up and where the object is moving at constant velocity, and finally, where is the object slowing down? So I want to know, where is my object speeding up, where the object is moving at constant velocity, meaning no acceleration, and where is the object slowing down, where? Okay, so you pause the video. Here, the velocity in zone 1, the velocity is going from 0 away from 0. So in zone 1, speeding up. Here there is no change. Here the velocity is going from 10 meters per second towards 0. So whenever you are stopping, you're going towards 0, you are slowing down. So in zone 3, you're slowing down. But then in zone 4, what's happening? You reach 0. Okay, so you're moving to the right, let's say, and then you decided, okay, you were speeding up. You sped up from 0 to 10 meters per second in 1 second, which is not really realistic. Okay, in your cars usually reach 2 meters per second squared, 3, 4, but not 10 meters per second squared. That's more like a roller coaster. And then you went at 10 meters per second for 1 second. And then you said, oh my God, I forgot my wallet at home. So you wanted to go back. So how are you going to do that? You are going to slow down and then go back in the other direction. But then in the other direction, you're going to speed up, but in the negative direction. So all this here is happening in the negative direction. All this here is happening in the positive direction. Here you're speeding up in the positive direction, constant velocity in the positive direction, slowing down in the positive direction, speeding up in the negative direction, constant velocity in the negative direction, and then slowing down again in the negative direction. So whenever your velocity, this is the 0, whenever it's going away from 0, it means that you're speeding up. Whenever the velocity is going towards the 0, whether you are in the positive direction or the negative direction, you are slowing down. So here, velocity is going away from the 0. Here it's constant. The velocity is going down towards the 0. This is the 0. Away from the 0, so you're speeding up in the negative direction. You see, if we say Dubai and Abu Dhabi, Dubai to Abu Dhabi is positive, and then from Abu Dhabi to Dubai is negative, it doesn't mean that you cannot speed up in both directions or slow down in both directions. So here you're speeding up in the positive direction, and here you're speeding up in the negative direction. And you're slowing down in the positive direction, you're slowing down in the negative direction. I really hope that this clarified a little bit the concept. If you have any more questions, let me know. Okay? Okay. Don't play Fortnite just yet. Okay, review.